I have to find the currents I1, I2 and I3 in this circuit. This is a current dependent current source, and it's just I1. That means this current is also this I1. Now between loop current method and node voltage method, I would prefer node voltage method to solve this problem. So I will identify the two nodes here. This is one node, let's call it node 1, and then node 2, and this is the reference node. So once I have it, the voltage here is V1, the voltage in this at this node is V2. So if I write the KCL at node 1, that will be V1 over 2. I am writing in terms of V1 minus 10 over 2, because this voltage is 0 plus 10, so this point's voltage is 10 volts. And then this is one node, so this is the downward current is I2. So I can write instead of writing I2, I will write in terms of the node. So V1 V1 over 1, and then this current is going in this direction. The current's this is 2 ampere. This current's value, this was in the problem, I missed that. So that current is going away, so it's also 2. And yeah, these are the last equation is this one, which is this current, which is I1, but I will write in terms of V1 minus V2 over 4, like that. In terms of V1 and V2 I'm writing. So that's this equation here, and then I can rearrange this equation. I can multiply by 4. So 2V1 minus 20 plus 4V1 plus 8 plus V1 minus V2, that's 0. So it's becoming 7V1 here, and on the right hand side I can write V2 plus 12. 20 minus 20 plus 8 is minus 12, going on the other side, so plus 12. So that I leave it like that. I'm writing V1 in terms of V2. So that's there. Now for the other node V2, I will write the equations. The entering current is my 2, so I'm writing it on the right hand side. And then there is this leaving current, this one, which is I1, plus this one is V2 over 3, V2 over 2, sorry, V2 over 2, and then finally the current is I1, negative I1. So in this case I would prefer writing in terms of I1, because I already have an I1 here. So this current is entering current, so this current will be negative I1 if I write on the left hand side. So that will be negative I1. Basically I was writing the entering current on the right hand side, that's why 2 was on the right hand side, but this one I'm writing negative on the left hand side with a negative sign. The reason is now I can see that the I1 getting cancelled because they are same value. So what I get, I directly get V2 here as 4 volts. And once I have V2, I immediately have I3, because I3 is V2 over 2. So that's 4 over 2, that is 2 ampere. That's what I get directly. Now I need to find V1, and I have that 7V1 is equal to V2 plus 12, V2 plus 12. So V1 will be, V2 is 4, so 16 over 7. That's 2.286 volts. So I need the other two currents, so I can see that I2 is basically V1. It's V1 because I2, this current is V1 over the resistance, which is 1 ohms. V1 over 1 ohms. So I2 is becoming V1 over 1, which is 2.286, same value in amperes. So that I get. Now I have only I1 left, and I1 is V1 minus V2 over 4. So V1 minus V2 over 4. So V1 is 2.286, V2 is minus 4, and that is 4. So that is approximately negative, of course, 0.4286 amps, or in terms of milliampere it can be written 428.6 milliamps. So that's the value of I1. So I have all the three currents here. I1, I2 and I3 was here.